we had all these commercials on TV for cereal boxes, where they would put a little prize in the box, and there'd be like a whole collection. And so let's suppose that, let's say Kellogg's is trying to market their cereals, and they put a little toy in each box. And there's 8 different toys. And let's say they're randomly put into boxes, which is not realistic, but how many boxes do you think you would need to buy to get all 8 toys in the collection? And they still do this now, right? Cracker Jacks and other kinds of things. So just think about it. There's 8 different prizes, and you want the full collection. How many boxes of cereal do you think you would have to buy so that your kids can have all 8?
About 1,000 get the same one. So is there a way to figure out how close?
Now, just gut feel. What do you think? Debbie says a lot.
Having all 8 would be better.
Now, this is math. You don't say a lot. You say how many. Okay. Let's see what does this table say? It'll never be guaranteed. Likely.
64.
Okay, 64. Edmund says 1 million.
I said 15.
All we would need is one customer going for 1 million boxes. How many over here? How many boxes?
Less than 64.
Less than 64. This is not the Price is Right.
I say less than 1 million.
There you go.
We know it's less than
Infinity.
64.
Infinity. So we that's countable or not countable?
16 million.
All right. So we got a pretty big range, don't we? So,
15 to 16 million.
16,777,000.
all right. So here's an activity we do that deals with it, and then I'm going to sort of move it into dice. Earlier when we were talking about spreadsheets, the issue came up about random number generator. There's actually one in the calculator, and I'm going to show you how to use it. So just watch along. Well, it's not working out, but we'll figure that out. My pen over there.
You should have one of each.
Somehow the mouse is not working. And
16
now it's working. Well, for some reason it's not working. We'll try it with.
She's one of hers. And she
does.
No, he's not working.
Next one is say that there's a chance of getting one meal. Next one, she has a 6 out of 8 chances. That's assuming not the time.
That's great. You missed 5 minutes ago. I'm going to shut it. Open it up again.
Closer to 17 million than 16 million.
Let's try it. All right, here we go. Let's try it now. Okay, in a graphic calculator, we're going to have directions up on how to use this. This thing is just filled with features, and there are probability features. So I know now there's probability topics in 6th, 7th, 8th. Actually, a bunch of probability statistics has gone into Algebra 1 and Algebra 2. Now, the calculator has a random number generator built in, and it's just called It gives you a random number between 0 and 1. Now, we want 8 boxes. So how can we convert a random number between 0 and 1 to 1 to 8 prizes? What might we do?
Has to go. Multiply by 8.
Good. Okay, so we multiply by 8. So we're going to insert an 8. Right? Good idea. So it's going 0 to almost 8. Okay? Again, how do we get it to show 1 through 8 randomly? That's not in rand. That's in the shortcut that they added years later after putting this in. Okay. Now, that's really good, but when I'm teaching people how to use this, I want them to know what the machine is doing, but we will actually get to that. What else could we do? Well, it doesn't really hit 8, does it? So how can we get it up to 8?
Add 1.
Add 1. Very good. See, we're getting closer. Right? So now we're going over 8 a little, aren't we? So we're getting numbers 1 to 8, but we have some decimals beyond it. What do you think we could do?
Slide the screen over so we can only see up to.
Oh, I like that. Slide the screen over. What do you think we could do? Well, we can insert something. How about just the integer part?
Yeah, I love that.
Good thinking.
Yeah.
Okay, so the first box we buy, we get prize number 6, prize number 5, prize number 4, prize number 8. What do you think? Is it going to take 1,000,000 boxes?
No.
Not at this rate. Now we get 2 5s. What are we missing here? 1 and 7.
Oh, there it is.
Well, what do you think?
That's
Now,
nice.
it's experimental, isn't it? And we can do it again, and we can do it again. And it turns out it's only about 21, 22 boxes on the average. Most people think it's way higher than that. We do get millions and 400, and we get a lot of 64s because people square the 8. When I asked them why did they square the 8, they said didn't know what else to do with it. But
isn't it like 1 out of 8 chance, and then you get 1, so then 1 out of 7 chance, 1 out of 6.
and that's how you would calculate the expected value. 8 over 1. But here's a way to show the experimental. Now, one of the SOLs is experimental versus theoretical probability. And this is something that kids can relate to because they buy stuff and they want to win prizes. Now, there's a quicker way to do this. If you go into math, and someone said it before, the early versions of all the TI calculators had rand, and then they added later on random integer. Because most people who were using rand were using it to do something like I just showed you. But there were a number of steps you had to go through. The steps were actually good for kids to think about, truncating and rounding and scaling and all that kind of stuff. But they made it a little bit easier. And now you can put rand between 1 and 8 and just do that. But it's the same thing. All the calculator is doing with rand int is all those steps that I just showed. Now there's another advantage of rand int, and we're going to show that in terms of coins. Okay. What I did here was I graphed, dice. What I graphed was number of 1s, 2s, 3s, 4s, 5s, and 6s with 50 coins, with 50 tosses of a die. So we got 4 1s, 8 2s, 11 3s. So you can do histograms, which is also part of their SOLs. The way to do this is I put these values in a list, and I put ran int 1 to 6. Okay, after that second comma is a 50. And that tells the calculator do it 50 times. You can put 100, you can put 500, and so on. And it will just do all of them. You can see them listed. And then you could do a stat plot where everything in list 1 was plotted in a histogram. And there it is. Now, recalculate it, right? They're different numbers now. Every time you do it, you get a different set. Now, if you want the kids to understand something about the law of large numbers, you do this first with 10, then you do it with 30, then you do it with 100, then you do it with 250, and they see as the numbers go up, the thing starts to level off. And it's a good way to do it experimental and connected to the probabilities. Something they could all do on a calculator quite easily. Do you want to show them anything else on the?
I don't know. I think the point that we just want to kind of drive home is that the probability stuff, the data analysis stuff that you can do in Excel, you can do on a calculator. So if you don't have access to laptops that day, access to the computer lab that day, if you have a set of graphing calculators, you don't have to abandon your lesson activity or anything like that. Everyone gets their own handheld. They type in, or put this up on the smart board. Again, you can come and push all the buttons if you have smart view. That's what this is called, TI-84 Smart View, not to be confused with Smart Notebook, which I do all the time. So the graphing calculator basically has all of the same capabilities as Excel. It's not as pretty, and you can't obviously change the colors and do all those fun things, but you can still get all of those mathematics out of it. With scatter plots, histograms, box and whisker plots, especially all of those new SOLs that they just put in there with the data analysis and probability.
Yeah, so the graph will do every one of those things.
Yeah. So basically, if you don't have access to computers or Excel, then the graphing calculator is a really good second option.
Now, I want to show something else.
Or if they take it home, they can take it home if they have access to the calculator at home and maybe not the internet or not the computer, they can still do the homework and stuff.
So my understanding, because we're sitting over here saying we don't have this type of calculator, what Becky asked me to do is just keep a list of things that we might need as resources. So I'll add this to the list, because I assume none of us have it.
You're talking about the program.
Yeah.
We
We don't have the program though.
The program.
Is that correct? I'm asking what I'm asking for.
Correct, we do not have it.
Yeah.
I mean, you can either do the program or you can do it on the calculator.
You do have it, Kelly?
I don't have the program that I use.
It really is a great program because you can copy and paste screenshots out of it.
Yeah, like
And
into a
it
Word
also
document.
allows you to do one other thing. There's something called a cube view up here.
Yeah.
Okay, so what cube view will allow you to do is see all of this kind of stuff at the same time. It shows multiple views.
So if you're doing lines, graphing linear equations, you can see the table, the y
I'm
equals
going
the
to put the
equation.
window here. Right, so it'll show you the window, and it'll show you, well, we can take that table out because we're not using that one, so we can put something else in there. So if you want kids to connect these representations, right, there's the graph window. There's the list of the values, and there's the graph. And you can switch all of that on and off with a right click. This is a great way to help kids connect representations because they can see them all at the same time. know, where does that 5 show up? It shows up over here. Where does that 3 show up? Why is the window the way it is? So there's a lot of different questions you get asked. And as you change them, you can see how the whole thing changes.
And then, yeah, like Joe was saying, this little button right here, you click it, it automatically makes a screenshot, and you can either keep this open or close it, and say I want to do a screenshot of the actual list.
Now you got to go into do stat lists that have screenshots in there and say, you know, here's the numbers. What is the graph going to look like? I'll connect this to that. You can just, it's very easy.